Students, today we will discuss about the magnetic effect of electric current. Electric current carrying wire behave like a magnet. Electric current carrying wire behave like a magnet. In 1820, Hans Christian Ørsted accidentally discovered that a compass needle got deflected when an electric current passed through a metallic wire placed nearby. Through this observation, Ørsted shows that electricity and magnetism were related phenomena. What is magnetic field? The space or the region. It is the space or the region surrounding a magnet. It is the space or the region surrounding a magnet in which another magnet experiences a force of attraction or repulsion is called magnetic field. Magnetic line of force. Magnetic line of force is defined as the path along which the unit north pole tends to move. In which the unit north pole tends to move. Place a bar magnet at the center of the cardboard. Sprinkle some iron filling on the cardboard. Now tap the board gently. We observe that the iron fillings arrange themselves in a pattern. Now put a magnet and sprinkle some iron filling and now tap this, and after some time you will observe that these iron fillings are arranged in a line, and these are the magnetic line of force. Now what are the properties of the magnetic line of force? Magnetic field are closed continuous curve. Magnetic field are closed continuous curves. They come out from the north pole. They come out from the north pole, from the outside of a bar magnet, and go inside the south. Go inside the, coming from the north pole, and from inside the bar magnet move from south to north. Inside the magnet they move from south pole to the north pole. The region where the magnetic field lines are crowded, magnetic field is stronger, and when they are apart from each other, field is weaker. Here they are crowded. Magnetic line of force are crowded, so that there is the maximum or the stronger magnetic field. Line of force do not intersect or cross each other. Third property is that the magnetic line of force do not intersect or cross each other. If they do so, it would mean that at the point of intersection, the compass needle would point towards the two directions, and this is not possible. Now, magnetic line of force between the two magnets. When the unlike pole face each other, unlike north and south pole are facing each other, these are the two bar magnets, and opposite pole are facing each other, then there is the force of attraction, and the magnetic line of force move from the north to south. But when the like pole faces each other, north if north is faces, then these magnetic line of force move from the north to the opposite side, and this show the force of repulsion. If the south are facing, then the magnetic line of force move towards the south inside the bar magnet, and they also show the force of repulsion. Now, what is the magnetic field due to a current carrying straight conductor? If we take the straight conductor, then how the magnetic field depends? Ørsted experiment proved that current carrying conductor always produces a magnetic field. A current carrying conductor always produces a magnetic field. This causes the deflection in the magnetic field placed near it. Now, what are the factors affecting the magnetic field strength? Magnetic field strength produced by a straight current carrying conductor at a point depend on the magnitude of the current and distance from the wire. It depends on the magnitude of the current and distance from the wire. Right hand thumb rule. Right hand thumb rule. This rule is used to find the direction of magnetic field due to a stray current carrying wire or conductor. It states that if we hold the current carrying wire in the right hand in such a way that the thumb is stretched along the direction of current, if we consider this is a wire and if we hold this wire in the right hand in such a way, then the finger represents the curly finger around the wire or conductor represents the direction of the magnetic field and the thumb represents the direction of the current. The magnetic field due to a current carrying circular wire. Now we will discuss about the circular wire or circular coil. A current carrying circular coil behave like a magnet. The direction of magnetic field of every section of the circular loop can be found by applying the right hand thumb rule. The field lines will be the same direction with the circular coil. The direction of the magnetic field at the center of the circular coil is perpendicular. This is the perpendicular to the plane of the coil, that is along the axis of the coil. It is directed outward for anti-clockwise flow of the current. This is clockwise and this is anti-clockwise. Anti-clockwise flow of the current while inward for clockwise current flow. Unit of the magnetic field is Tesla or Weber per meter square. Weber per meter square. Now what is solenoid? A coil of many circular turns of insulated copper wire wound or wrapped on a cylindrical insulated body such that its length is greater than its diameter is called a solenoid. This is a solenoid, and wire circular turns are wrapped on this. One end of the solenoid behave as a magnetic north pole and other as the south pole. The field line inside the solenoid are in the form of parallel straight lines. This indicates that the magnetic field is same at all points inside the solenoid. That is the field is uniform inside the solenoid. A strong magnetic field of magnetic material like soft iron when placed inside the coil. The magnet so formed is the electromagnet. Means a magnet is formed by the use of the electricity. That type of magnet is formed is called electromagnet. Force on a linear current carrying conductor in a magnetic field. We have learnt that current carrying conductor produces a magnetic field which exerts a magnetic force on the magnetic needle placed near it and thereby deflecting the needle. Force is maximum when current carrying conductor is placed perpendicular. Force is maximum when the current carrying conductor is placed perpendicular to the direction of magnetic field and maximum displacement occurs. Current carrying conductor does not experience any force when it is placed parallel to the direction of magnetic field. It should be perpendicular. This is of determining the direction of magnetic field. Direction of force acting on a current carrying conductor get reversed if the direction of the current flowing through conductor is reversed. When the direction of the force reversed, if the current flowing through the conductor is reversed and magnetic field is reversed, the direction of force acting on a current carrying conductor in a magnetic field can be found by the Fleming left hand rule. Fleming left hand rule. Stretch your thumb, forefinger and middle finger of your left hand in such a way that they are mutually perpendicular to each other. They are mutually perpendicular to each other. Forefinger mean field, center finger mean current, and thumb mean the direction of force. Now Fleming left hand rule. Stretch the thumb, forefinger and middle finger of your left hand such that they are mutually perpendicular to each other. if the forefinger point direction of magnetic field, middle finger point direction of the current, and thumb will point the direction of motion or force acting on the conductor. This is called Fleming left hand rule. Motor is a device which converts electrical energy into mechanical energy. To get the rotational motion is called electric motor. What is the principle of motor? Fleming left hand rule. If a current carrying rectangular coil is placed in a uniform magnetic field, then according to the Fleming left hand rule, its two arms experience parallel, equal and opposite force having different line of action. The action of combining these two forces make the coil to rotate. Construction. It consists of the rectangular coil. It consists of the rectangular coil. PQRS. PQRS. This is a rectangular coil. This is called armature. Insulated copper wire are suspended in a uniform magnetic field. The end of the rectangular coil are connected to the two copper metallic split rings. These are the split rings. It is divided into two parts or split in two parts. That's why it is called split ring. C and D. It rotates along with the coil. The function of the commutator is the reverse the direction of the current through the coil after every half rotation. The external sources such as battery send the current to the coil through the key and conducting stationary brushes. These are the brushes X and Y. These are the two brushes slide over the split ring C and D. Now what is the working of the motor? Consider at the beginning the arm P, Q and RS are perpendicular to the direction of the applied magnetic field. These are the perpendicular just like this. PQ and RS are perpendicular to the direction of applied magnetic field. Let the current in the coil flows along with the path PQRS. This is the current pass from PQRS. Then according to the Fleming left hand rule, a downward force acts on the arm PQ, pushes it downward. PQ, just like this, PQ move downward and RS move upward. PQ pushes it downward and an upward force on RS pushes it upward. These forces cause the coil to rotate in anti-clockwise direction just like this. This is at the parallel position, then it moves it into the anti-clockwise direction about its own axis. After completing half rotation, it will again move due to the split ring interchanges, due to which direction of current in the coil get reversed and the current flows along the path FRQP. Again, according to the Fleming left hand rule, the force acting on the arm PQ and RS also get reversed. This makes the coil to rotate and complete the next half cycle of rotation in the same direction. First at move P and Q move downward, then it will change direction and complete its rotation, full rotation in the same direction. Thus the interchanging of split ring at each half turn make the coil to rotate continuously in the same direction as long as the current is passing through it. Power of electric motor can be enhanced by using an electromagnet, increasing the number of turns in the coil and using a soft iron core. Now what are the uses of the motor? Electric motor are used in the electric fan, water pump, mixer, refrigerator, washing machine, computer, DVD player, etc. Now what is electromagnetic induction? The changing magnetic field linked with the closed circuit causes current to flow through it. This current is called the induced current and the phenomena is known as the electromagnetic induction. The direction of the induced current in a closed circuit is such that it always opposes the cause due to which induced current is produced. For example, when a north pole of a magnet approaches the coil whose ends are connected to the galvanometer, its needle gets deflected in a particular direction. This shows that current is induced. If it shows deflection, it means that current is induced or produced in the coil and it is anti-clockwise direction. This means that the face of the coil towards the magnet acts as the north pole. If north pole move away from the coil, same faces will now act as the south pole of the needle and as has deflected in the opposite direction. Current in the coil is also induced when south pole of the magnet approaches the coil or pulled out from the coil. When magnet is stationary with respect to the coil, if the magnet is stationary, then no current is induced. Only current is induced when we move the magnet. In the coil, the magnetic field line of force passing through is called a magnetic flux. Induced current without magnet. Two circular coil of insulated thick copper wire having different number of turns are placed near each other or wound over a non-conducting cylindrical roll. Change the electric current through the primary coil. This is the primary coil. Now change the electric current in the coil A either by rotating or stopping or by varying the current with the help of the rheostat. It is found that whenever the current through primary coil is changed, if we change the current in the primary coil, a potential difference is induced in the secondary coil. Coil B. This is the coil B. The reason is that when the current in the primary coil changes, the magnetic field is produced around it. Whenever we change the current in the coil A, then the magnetic field will be changed or produced. Some magnetic field lines will pass through the secondary coil also. Therefore, due to change in the magnetic field lines around the secondary coil, a potential difference is induced in it and hence current is induced or produced. So as long as the current in the primary coil is changing, an induced current flows through the secondary coil. As we change the current in the primary coil, induced current flow in the secondary coil. A transformer used up to step up or step down the voltage is based on this principle. Fleming right hand rule. Stretch your thumb, forefinger, middle finger in such a way that they are mutually perpendicular to each other. Then the forefinger means magnetic field, center finger, C means current and the thumb represents the direction of the motion. Now, if we stretch the thumb, forefinger and middle finger of right hand that are mutually perpendicular directions such that forefinger indicates the direction of magnetic field, thumb shows the direction of motion and center finger shows the direction of the induced current. Electric generator. It is a device that is used to convert the mechanical energy into the electrical energy. Now what is the principle? It is based on the principle of electromagnetic induction. When a closed coil is rotated in the magnetic field continuously, then induced current flows in the direction given by the Fleming right hand rule. Electric generators are of two types: alternating current generator or AC generator, direct current generator or DC generator. Both the generators work on the same principle, that is electromagnetic induction. Construction. It consists of the armature A, B, C, D. This is the armature. This is said to be armature A, B, C, D. And a rectangular coil ABCD having a large number of turns of insulated copper wire wound over a soft iron core. Field magnet. There are the two magnets, north and south. It is a powerful magnet whose poles are in the concave shape. Slip rings. These are the S1, S2, two slip rings. The end of the rectangular coil are connected to the slip rings, which also rotate with the coil. In AC generator, we use two slip rings, S1 and S2. But in DC generator, split ring, not slip ring, split rings type commutator R1 and R2 is used. Brushes. The two stationary brushes. These are the B1 and B2. Two stationary brushes are always in contact with the slip ring in AC and split ring in DC generator. These brushes are connected to the external circuit, that is output of AC generator. Let the armature coil ABCD rotate in the clockwise direction. ABCD, that is rotate in the clockwise direction in the magnetic field. Magnetic flux change, hence the induced current is flows in the direction ABCD according to the Fleming right hand rule. At this instance arm AB move up and CD move down. AB moves up and CD moves down. Hence, the direction of current in the coil reverse. Net induced current flows in the direction, that is DCBA. Therefore, the polarity of the induced current between brushes B1 and B2 changes after every half rotation. Such current is called the alternating current or AC current. It is the bidirectional current because it changes its direction alternatively or periodically. And this is the graph for the AC generator. It will change the direction. Now, working of the DC generator. This is the DC generator. This is AC generator. Working of DC generator. When armature ABCD rotate in the magnetic field, the number of magnetic field line changes. Hence, according to the Fleming right hand rule, the direction of current in the arm of a coil reverse after every half rotation with the help of the split ring commutator. One brush is at all time in contact with the arm moving up and other brush is in contact with the arm moving down, and one brush is in contact with this arm and one brush is in contact with this arm, and an induced unidirectional current always flows from B1 to B2. Such current is called DC or direct current. This is the graph for the direct current. It will not alternatively change the direction. Alternating current or AC. The current which changes direction after equal interval of time, that is the current which reverses the direction periodically, is called alternating current. In India, the frequency of AC is 50 Hz. It means AC changes its direction after every 1 by 100 seconds, that is after every 1 by 100 seconds. Current changes its polarity. The circuit symbol of AC is this. It is bidirectional and changes periodically. Direct current or DC. The current which flows in one direction, that is, it is unidirectional. Direct current is obtained from the batteries, solar cell and DC generator. Now, what are the advantages of AC over DC? AC generation is cheaper than that of the DC. AC voltage can be stepped up or stepped down with the help of the transformer. AC can usually converted into the DC. AC can be transmitted over a long distance without much loss. AC devices are highly efficient, more durable, less expensive, and are simple in their functions. Now, what are the disadvantages of AC? Disadvantage of AC alternating current is it is dangerous to use due to its high peak value. So, better insulation is required. Now, the domestic electric circuit. AC is used for domestic purpose. It changes direction to insulated wire. First wire is live wire, second is neutral wire. Live wire maintain 220 volt, neutral wire maintain 0 volt. Potential difference is 220 volt. A third wire, earth wire, is also used in the domestic circuit as a safety measure. Live wire is red and brown insulation. Neutral wire insulation is black and blue, and earth wire insulation is green and yellow. Now, there are two types of the circuit, lightning circuit and power circuit. Lightning circuit is of 5 ampere and power circuit is of 15 ampere. Earthing. The arrangement of connecting the metallic body of an electric device to a copper plate buried deep in the earth near the house, and this is called earthing, and the wire used in the earthing is called earth wire. Function: earth wire provide low resistance path to the leakage current. What is the necessity of earthing? Any leakage of current by the electrical appliance is immediately transferred to the earth through the earth wire, and user or person is protected from the dangerous shock. What is short circuit? When resistance of the circuit become very small. When the resistance of the circuit become very small without connecting any extra load, a large amount of the current flows through it, and this is called short circuiting, and it can cause due to the failure of insulation. When insulation get failure, then two wire come in close contact or direct contact with the neutral or earth wire, then the current become very resistance become very small. Use of less rating wire can be cause short circuit. What is overloading? If the current drawn by the many electrical appliances connected to a single socket, if many appliances are connected to the single socket that exceeds the current rating of the wire, the entire circuit gets heated up and even can cause fire. This is known as overloading. It is due to the accidental hike in the supply voltage. What is the cause of overloading? It is accidental hike in supply voltage, or maybe connecting too many appliances to a single socket, or it can damage caused due to the damage in insulation of wire. Now, protection of circuit or fuse. Fuse, what is a fuse? Fuse is a safety device and it will protect the circuit and it is connected in series with live wire prevents the appliance and circuit from the damage. When current passing through the fuse wire exceeds to its maximum limit, a large amount of heat is produced which melt the fuse wire and stop the flow of current through the circuit. This saves the appliance from the damage, and fuse is the protecting device. Thank you.